See, I'm lost for words at times. So come on, someone help
me. Memes here has a question.
What am I looking for? What's the word I'm looking for?
May I attempt to steal Dr. Pius's, Brother Pius's opinion here for a second? If Jeremy could share my screen for just a moment, just because seeing some visuals rather than like laying off all these different my screen down below. But basically saying all these words, G, big G over this. I'm a very visual person as well, so I'm a noob, so I just go to Wolfram Alpha. I type in Planck Force, aka the Super Force. Okay, as we can see, we have our C4 over our big G, speed to the fourth by the Newton gravitational constant. It gives us these numbers right here, 10 to the 44 newtons there. All right, and then we take equation 1. We plug in. You can literally just on Wolfram Alpha, like just plug in just natural language these terms. Planck mass times c squared, so just carry it up to the second, divided by the Planck length there. We subtract out just mass of universe, so we have the universe mass, ordinary matter that we're trying to account for, times c squared, speed of light squared, divided by the radius of the observable universe as we know. And it is very interesting. It does come out to be very close to the magnitude, about 0.7 there, the Planck force, which is interesting because if we're going to try to account for perhaps some dark mass effect, whether that's a dark matter particle, a neutrino, a black hole, anion, whatever flavor it might be there, that is an interesting thing. So I believe that what Dr. Pais, the claim is, and part of this maybe is a bit of a mistranslation here, is very often if you're making a claim, I feel the way you wrote the paper, sir, is you're kind of saying it's evident there. And it might be. It might actually be the truth. I don't know that, but very often from what I've listened to Professor Wolfram in a lot of his lectures and live streams, he'll say, the claim is this. So let me try to restate this. So the claim is that there seems to be a relationship on the very large, utilizing the superforce, the Planck force, because there does seem to be maybe some correlation there with what might be going on the very large.
But that's why I didn't use the equal term. I used that squiggly line meaning on the order of.
Right.
Boom.
Right. So that's what's this.
Don't forget there could be that 8 pi in there that we don't really know. That 8 pi is essential, and I think it talks to a geometry. There's some geometry, there's some physics going on. That 8 pi should be looked into. That 8 pi maybe is in there. In which
wait, we're getting there. I'm sorry to cut you off, sir. But when you take, as you were saying earlier, 1 over the Planck force, you get all these crazy numbers here. But the one popped out. I'm like, the Einstein constant from the C4 convention. So I explored if there was perhaps a geometric representation of this. I'm like, oh, that last number was a 9. That's an 8 followed by an 8. That looks like 1 over 8 pi. I mean, that's pretty neat there. So, I mean, there's cool stuff here. Do I know it's right? I don't know. I just feel like we should give a fair shake. And to be fair, if you are putting terms in here, I believe the claim that you're making that if you construct it, the Schrodinger equation in a particular way, you've made some observations. And again, it's very often the Schrodinger equation is for like ground state of hydrogen or whatnot there. And we believe it works to the best of our knowledge. And then getting past there is very difficult.
It's a fundamental equation, but it shows reality, shows physical reality. All I'm asking is if Planck's energy comes out of it, if the Boyle's wavelength comes out of it, and the superforce comes out at the Planck scale, that cannot be circumstantial evidence or whatever you want to call it.